All right, 6.8, trigonometric inverses and their graphs. All right, so we're going to draw the three main inverses. Inverse sine, inverse cosine, and inverse tangent. To do that, we have to first look at the graphs of the originals. So we're going to first graph y equals sine of x. This should really be second nature at this point in time. We're going to draw it on increments of 45. Okay. So where does the sine start? Again, it's 0. So we start at 0, and then we're going to go to about 0.7, and then 1, and then 0.7, 0, and so forth. Negative 0.7, negative 1, negative 0.7, 0. Continue the pattern to the left. So we have the sine graph. The inverse of sine that's sine to the little negative 1 of x. Inverse is not the same as a reciprocal. Okay? Don't think of it that way. Don't think of any inverse that way. When you hear the word inverse, you should think that we switch x and y. Y becomes x, x becomes y. And the same thing happens graphically. Okay? To draw the inverse, we're going to switch all these points. Okay? What was x becomes y. So let's go ahead and try to redraw this. We need a little bit more room. Now you're going to want to make your axis longer vertically than horizontally. Because x becomes y, y becomes x. Our x-axis, which was what? Radians in terms of pi, right? Pi over 4. If that's our x, now it's going to be our y. So I'm actually going to label my vertical axis in terms of pi over 4. Same thing in a negative direction. And then 1 and negative 1 will now be my x-axis because that was my y. So x becomes y, y becomes x. That's what the inverse is all about. So we're going to take our points, and we're going to more or less try to draw it now. Flip. We started out at 0, 0. Now at 45, or pi over 4, where were we at on the sine graph? 0.7. Okay. So, it's about right here, right? Follow me? At pi over 2, where was I at? 1. At 3 pi over 4, and then back to about 0.7, right? And at pi over 2, I'm sorry, not pi over 2, how about just pi? At pi, we're back to 0, right? Okay, so you see the pattern here. And we'll continue that now. So now I'll go at 5 pi over 4, we're going to be at negative 0.7. At 3 pi over 2, we're going to be at negative 1. And then 0.7, and then 0. We'll get back to 2 pi. And we'll continue that pattern down here. So we can actually start drawing this if you want. As best as you can. It's probably going to look a little bit better than mine if you have graph paper. So we're going to go at negative 45 and go about 0.7. Negative pi over 2 is going to be negative 1. Negative 3 pi over 4, back to 0.7. And then negative pi, 0. Negative 5 pi over 4, positive 0.7. 3 pi over 2 negative. 1. That's a little off. Then 0.7, and 0, and we get back to negative 2 pi. Right. Because x becomes y, y becomes x.
Is that true for all of them?
All inverses. So if you had let's just say a curve here. I'll just draw one on the side here. Let's say you had this parabola. Okay, this is your y, this is your x, right? If I switch it, what's going to happen? Y is going to be here, x is going to be here, right? Where was that one pointing towards? No, I'm not actually going to label the axes different. This is still the x, this is still the y. So, you know, I'm going to say this is x, this is my y, but what's happening is they switch. So this would be the inverse. This is y equals x squared, and the inverse of that, close. Yeah, well, yeah, exactly. Exactly. X equals y squared. If we solve for y, it would be y equals plus or minus the square root of x. But x equals y squared is right. That's perfect. So that's more or less what we're doing over here with the sine. Now, is that a function? Why not? Doesn't pass the vertical line test. But I'm calling it the inverse sine function. Right? So can I keep all of that? No. I cannot keep all of that. Okay? I can only keep part of it. What part can I keep and have it still pass the vertical line test? Any suggestions? Yes? I agree. From one, well, we used to say max and min, right? They're not really max and mins now, but about from, say, this point. this point. Would that pass the vertical line test? Yeah, that's all we keep. That's the graph of the inverse sine.
Do we have to draw the whole thing?
Nope. How much do we need? How far does this go? From what to what? Correct. From negative pi over 2 to pi over 2. That's all the further we really need to go. All right, let's take a look at on the graphing calculator, just to show you what this looks like. Second sine will be our inverse sine. Okay. I'm going to do a zoom trig, zoom 7. Now mine is much flatter. Okay, let me zoom in on that once so you can see it. That's not real good. Just change the window. What's my window here? Negative 1 to 1. So negative 1.5 is not bad. Y min, Y max. What is the approximate decimal of pi over 2? What's pi approximate? Or even 3. That's a close estimate, right? What's half of 3? 1.5. So I have to go up and down to 1.5. I'm just going to say negative 2 to 2. You guys okay with that? Looks good to me. How do we do? Pretty close, right? It's pretty good. Any questions on drawing the inverse sine?
Well, what do you do for n equals greater than negative pi? Well, greater than pi over 2.
You won't have to worry about that. Because this will cover quadrant. What quadrants would this cover if we were doing circular? We're talking about it circularly. Okay. We're going from what to what? Negative pi over 2 or negative 90 degrees to where? Pi over 2 or 90 degrees. So it's going to cover quadrants 1 and 4. Any angles in there? Not 2 and 3. Not exactly. Cosine would cover 1 and 2. Inverse tan would cover 1 and 3. So you actually will hit them all. Okay. But you will be somewhat limited in what your answer will be. Most of the time, when we use the inverse, what are we looking for anyway? What's it represent? What's our answer? If I pick the point out here, 1 pi over 2. Okay, the y value is my answer, right? When I plug x equals 1 in, I get a pi over 2 out. Or I'm getting a what? 90 degree, an angle out, right? That's what pi over 2 is representing. So the inverse gives us angles. And you used it in geometry when you were solving triangles. I need to find that angle. We actually did it already this year. We used the inverse trig functions already when we were solving the the law of sines, law of cosines. You got a side, side, side. How do you find the angle? Took the inverse cosine, right? Okay. All right, so that's the graph. Let's take a look at the graph of cosine. Now, knowing that we have to limit the amount of graph that we're going to take, maybe I won't draw the entire graph like I did with the inverse sine. Let's draw the entire cosine first. so where do we start with cosine? 1. Then we go 0.7, 0, negative 0.7, negative 1, negative 0.7, 0, 0.7, 1, and so forth. Remember that does continue down. Go in the negative direction now. All right, so that's your cosine graph. You guys got that down, right? So again, I'm going to go longer on the vertical, shorter on the horizontal. Pi over 4 is the increment again. Except it's going to go on the y. Where's cosine start? 1. And then pi over 4 is at what? 0.7. Pi over 2 is 0. 3 pi over 4 is negative 0.7. And then pi is negative 1. Then we got 0.7, 0, 0.7, whoops, that's not right. 0.7, 1. All right, so all right, there's your cosine, inverse cosine. But it's not a function. All right? What part should we keep this time? Yep. Now, could have we kept 0 to negative pi? Yeah, we could have. We want positive answers when possible. So that's the only part that we need. So the rest, we don't need. So 0 to pi. Quadrants 1 and 2. Any questions on that one? So you're still drawing it. We're good? Yeah, take 30 seconds. If you're ready to go, you can start drawing the tangent. That's the last one we're going to cover today. Okay, I'm going to go ahead and get started with the tangent. All right, tangent, yes. Where's tangent start? Or you guys more need to build it? Does it start with an asymptote? Does it start at 0? Does it start at 1? Tangent is sine over cosine, right? Maybe this will help. Where's sine start? Where's cosine start? Okay, so where do we start? 0. Cotangent's the one that starts with an undefined. Okay. Pi over 4. Well, sine of pi over 4 is what? Approximately 0.7. It's an estimate. Cosine is about also 0.7. So we're at 1. Pi over 2. Sine is 1. Cosine is 0. Pi over 2, we have our vertical asymptote. Let's go ahead in the negative direction here. Negative pi over 4 would be negative 1. And then negative pi over 2 would be another vertical asymptote. And then we connect it up like a drain pipe. That's how it looks. So we're going to curve it out and up. As best as you can. And if you spread it out more, it's easier to make it look curved. Do I really need to draw anymore? Let me draw one more just to show you. All right, I'll draw another one. This does go on forever, right? It's the same pattern over and over and over again. We can just keep drawing that left and right forever. So, what's the inverse going to look like? Okay, guys, I ran out of space here. We go to the next page. Y equals the inverse tan of x. Okay, again, we want to go on negative. Pi over 4. Well, tangent started where? So this is going to start at 0. Where's pi over 4? At 1. Pi over 2? What happened to pi over 2? We had a vertical. What's this now? Horizontal. Exactly. Negative pi over 2. I'm sorry, negative pi over 4. We're at what? At negative pi over 2. We have another horizontal asymptote. Now let's draw this. It's going to curve out and get closer to that asymptote. Cool. What if I drew another one? Good. I'm going to draw it anyway just to show you that. So you get the concept here. What happened is We had all of those going vertical, stacked beside each other. Now they're all going to be stacked on top of each other. If I put more than one of those up there, it's not going to pass vertical line test. So anything outside of the asymptotes is not needed. So where are we limited to here? Same as inverse sine, right? We're going from 2 to the power of 2 to the power of 2. So I lied to you. Still, it's 1 and 4, not 1 and 3. Again, what does the inverse represent? The inverse trig functions. What are you finding when you type those into your calculator? An angle. Could be degrees, it could be in radians. It's an angle. That's what you need to understand. When you're taking a regular trig function, it's a trig function of an angle. So tan of x. X would be the angle. Is x an angle over here anymore? No. Because the inverse is switched. X becomes y. So y is an angle here. So our answer is an angle when you're talking about the inverse trig functions. Inverse sine, inverse cosine, inverse tan. Here, you take the tan of x. Okay? And what do you get when you do that? You get a ratio of sides. Tangent happens to be the opposite over what? Adjacent. And in calculus next year, you're going to find tangent lines. Guess where that comes from? This. You're going to talk about derivatives. You're going to find slope. And if you look at a triangle in the coordinate plane, you take the opposite side over the adjacent side, guess what you have? You have the slope of that line. That's all. That's going to be a lot of things you do next year in calculus with that tangent. Okay, so 3 trig inverse trig functions. We need to be able to graph them. And I think that's it. That's all I have for you today. So we'll just stop it there.